This is another video in my series on alternating current. In this video, I'm going to look at complex power. You can find this topic in my course entitled Power Analysis in AC Circuits. You can access this and my other courses on my Stan Store at this web address. So far, we have discovered that if we take the magnitude of the current in RMS values and multiply it by the magnitude of the voltage in RMS terms, we will come up with a term known as apparent power, which is short formed with the letter S average, and its units are volt amps, whose short form is VA. We can then represent the apparent power with a phasor whose length is that of the magnitude of the voltage times the magnitude of the current, and place that phasor at an angle of the voltage phasor minus the angle of the current phasor, and it will look like this. Now, if we draw a perpendicular from that phasor and project it onto the horizontal axis, we will make a phasor whose magnitude is the voltage times the current times the cosine of the voltage angle minus the current angle, and that will give us real average power. And that's designated as P average with units of watts, and it is short form is W. We also know or have learned that if we take the sine of the angle between the voltage and the current and multiply it by the apparent power, we will come up with a reactive average power, or Q average, and its units are volt amps reactive, and its short form is VAR or VARs. We also know that if we take the phasor of the real power and add it to the phasor of the reactive power, we will come up with S average, or the apparent power, and that is also known as complex power. And complex power can also be derived from multiplying the voltage times the current times the cosine of the angle between them, plus the voltage times the current and the sine of the angle between them. Or if you wanted to designate the term of apparent power as a phasor itself, it is the voltage times the current at an angle of the voltage angle minus the current angle. Moving right along, if we wanted to, we could rearrange that mathematically, keeping in mind the laws of multiplication of a phasor. Then we would have the voltage phasor, which is the voltage magnitude times the angle of the voltage times the current magnitude at an angle of minus the current angle. In mathematical terms, you can describe this as the voltage phasor times the current conjugate. The conjugate of the current is described as a vector, which is just the mere reflection of that phasor across the horizontal axis, such that if you have a phasor of I magnitude at an angle of, say, plus theta, then the conjugate would be the same magnitude of that phasor, but at minus theta, which would be described by the same magnitude, but at minus the angle. And that would be the current conjugate. This video is part of my electrical technical information series. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of aforementioned products, and it is also the connection to obtain a free copy of my 50-page electrical power crib sheets.